Alright, let's dive right into it. The first thing we need to understand about helium balloons and their magical ascent is the principle of buoyancy. You might have experienced this when you try to push a beach ball underwater at the pool.
It pops right back up, doesn't it?
And that's buoyancy at work. Buoyancy is the force that allows objects to float. Specifically, it's the upward force exerted by a fluid, like air or water, that opposes the weight of an object immersed in it. Now remember this. The force of buoyancy depends on the difference in density between the object and the fluid. Imagine you have a helium balloon in your hand. It's filled with helium gas, which is much lighter or less dense than the surrounding air.
This difference in density is what gives the balloon its buoyant force.
The helium balloon floats because the buoyant force acting on it is greater than the force of gravity pulling it down. In simpler terms, your helium balloon is lighter than the amount of air it displaces. So, the balloon rises, seemingly defying gravity. It's a bit like a tiny boat made of air, floating on an invisible sea of more dense air. That's the basic principle of buoyancy and how it allows helium balloons to float. It's a simple concept, but it's at the heart of a lot of physics and engineering, from submarines to hot air balloons to, yes, helium balloons. Stepping right into the next topic, let's talk about helium gas itself. Now, that stuff that makes your voice sound like a chipmunk when you breathe it in.
But there's a lot more to it than just that.
To understand why helium is the go-to gas for filling balloons, we need to consider its specific properties. Helium is a noble gas, which means it's highly stable and doesn't react with other elements easily. This makes it safe to use. It's not going to spontaneously explode or anything. But the crucial property of helium that makes it ideal for balloons is its lightness. It's one of the lightest elements in the universe, in fact. It's lighter than air, which is mostly made up of nitrogen and oxygen, both of which are heavier than helium. When you fill a balloon with helium, the balloon itself, plus the helium inside it, is still less dense than the air it displaces. This is why helium balloons float. They're essentially lighter than the air around them. In addition to its lightness, helium also has a very low boiling point, which means it remains a gas at temperatures where other gases would turn into a liquid or a solid. This property ensures that the balloon stays inflated for a longer time. So, combining helium's non-reactive nature, its lightness, and its low boiling point, it's not hard to see why it's the gas of choice for filling balloons. It's a fascinating substance, isn't it? And to think, most of the time, we just use it for party tricks and funny voices. Now that we've got a handle on the science behind helium balloons, let's take a step back in time to look at their history. The story of helium balloons really begins in the 18th century. However, at that time, they weren't yet filled with helium, but with hydrogen, another lighter than air gas. The problem was, hydrogen is highly flammable, which, well, let's just say it led to some explosive situations. Fast forward to the late 19th century. That's when helium enters the stage. Helium was discovered in 1868, but it wasn't until the early 20th century that we really started to use it in balloons. And for good reason. It's lighter than air, and it doesn't catch fire like hydrogen. One of the early uses of helium balloons was in meteorology for weather prediction. Filled with helium, these weather balloons would ascend into the atmosphere, carrying instruments that measured temperature, humidity, pressure, and wind speed. This gave us valuable data about the Earth's atmosphere. But helium balloons weren't just for weather prediction. They also played a significant role in exploration and scientific research. For example, in the 1930s, high-altitude helium balloons were used to study cosmic rays, and later, the Earth's magnetic field. In the mid-20th century, helium balloons even took on a military role. During World War II, they were used as barrage balloons to deter low-flying enemy aircrafts. It's truly fascinating to see how a simple concept, a balloon filled with a lighter-than-air gas, has found so many different applications throughout history, isn't it? From weather prediction to scientific exploration to military defense, helium balloons have certainly made their mark. Now, let's shift gears and delve into the mechanics of flight for helium balloons. Ever wondered why a helium balloon rises when released? Or why it eventually comes back down? It's all connected to temperature, pressure, and volume. When a balloon filled with helium is released, it begins to rise in the atmosphere. This is because the helium inside the balloon is less dense than the surrounding air, as we've discussed earlier. But as the balloon ascends and the atmospheric pressure decreases, the helium inside the balloon expands. This is due to something called Boyles Law, which states that the volume of a gas is inversely proportional to its pressure, assuming the temperature stays the same. As the helium expands, the balloon becomes less dense and continues to rise. The balloon will keep rising until it reaches a point where the density of the balloon matches the density of the surrounding air. At this point, the balloon will stay at a relatively constant altitude. Now, remember, we mentioned temperature. Well, if the temperature drops, like at night, or at very high altitudes, the helium inside the balloon will contract. When the helium contracts, the balloon becomes more dense and begins to descend. So the fascinating dance of helium balloons, rising and falling in the air, is a delicate balance of temperature, pressure, and volume. This interplay of factors is what makes the flight of helium balloons not just magical to watch, but also a delight to understand. It's a bit like juggling 3 balls at once, don't you think? You have to keep them all in the air for the trick to work. All right, let's now turn our attention to the use of helium balloons in transport. Yes, you heard that right, transport. Now, I'm not talking about tying a bunch of balloons to a house like in the movie Up. Though that would be quite an adventure, wouldn't it? No, I'm talking about things like airships and weather balloons. In the early 20th century, helium-filled airships, also known as dirigibles, were seen as the future of air travel. These giant balloons could carry passengers and cargo over long distances. However, the rise of airplanes and a few high-profile airship accidents led to a decline in their use. But helium balloons have seen a resurgence in recent years. Today, they're used in scientific research, meteorology, and even communications. For instance, Google's Project Loon uses high-altitude helium balloons to provide internet access to remote areas. However, using helium balloons for transport isn't without its challenges. Balloons are at the mercy of wind currents, which can make their paths unpredictable. Also, the use of helium, a non-renewable resource, raises environmental concerns. Environmental concerns. You see, helium is a byproduct of natural gas production, and once released into the atmosphere, it eventually escapes into space. With increased use of helium in various fields, there's concern that we might run out of this valuable resource. So, while helium balloons offer exciting possibilities for transport and other applications, it's crucial to use this resource responsibly. Ah, it's a bit like having a superpower, isn't it? With great power comes great responsibility.